This video will show you how to compute the volume of a solid by using a slicing method. The problem is as follows. The base of a certain solid is a region enclosed by y equal to 1 over x, y equals 0, x equal to 1, and x equal to 3. Every cross-section perpendicular to the x-axis is a square with its length across the base. Find the volume of the solid as shown in the figure. So we find that the base of a solid enclosed by y equal to 1 over x, which is here, y equal to 0, which is the x-axis, x equal to 1, and x equal to 3. Now every cross-section perpendicular to x-axis, you'll find that you're going to get a square. So every time you cut perpendicular to x-axis, you're going to get a square out. And this is how the solid will look like. Okay? The length of the square across the base will be the side of each square. How are we going to find the volume of this solid now? Based on Howard Anton text, you have a solid. If you slide them up into many slides, and then you pick up one slide, let's see, this is the blue slide here, you'll find that the volume of this slide is the cross-section area times the thickness. Thickness is delta x. So this is the volume of one slide. And then you add them up across all the slides. And the result, if the number of slides is going to infinity, or the thickness of each slide goes to 0, then this will result in integration v equal integration of ax dx, where ax is a cross-section area when x at the position x. So for our case, the ax we are going to find, this is the cross-section area, and we cut it at the point x here. So how is the area of this cross-section? So we know for a square, the area is the length of each side is square. So now what is the length of each side? So you know the base is the length is y, since y equal to 1 over x here. Since this is a square, so the height also y. So the area of the cross-section area is ax here, which is green area, is y squared. Now, what is y then? Y is equal to 1 over x. So this is 1 over x squared. So cross-section area is equal to 1 over x squared, or x power minus 2. So after we have found the cross-section area, then the volume is integration of ax dx. Our value of x goes from x equal to 1 to x equal to 3. So you integrate from x equal to 1 to 3. So this is equal to integration of 1 to 3. Cross-section area is x power minus 2. So when I integrate x power minus 2, you get x power minus 2 plus 1 over minus 2 plus 1 from x equal to 1 to 3. And this will give you v equal to minus 1 over x from 1 to 3. So putting x equal to 3, you get minus 1/3. Minus putting x equal to 1, you get this minus 1. So in the end, you get y minus 1/3. You get 2/3. So the volume of the solid given by this shape here, we find that volume is equal to integration from 1 to 2 of ax dx, which is integration of 1 to 2 1 over x squared dx is 2/3. That is the end of the recording.